Hey grade 8s, today what we're going to do is we're going to carry on with our shape and space unit, and what we're going to do is we're going to start calculating surface areas. So last day you started taking 3D objects that were prisms, and you started learning how to make them kind of flat so that you could create a net with them. And if you can do that, if you can take a 3D object and create nets, you'll be well set up to calculate surface area. So basically, surface area is just the area of all the sides of a 3D object. So it includes the top and the bottom and all the sides. So there's really three tools that you need to know to do this, and all these tools you've developed in previous classes. So first tool here is you need to know how to calculate the area of a rectangle. And you know this as, I'm going to write this just in formula form, area equals length times width. So you can see I don't put the operation in. You know that LW means length times width. Next one here is you need to be able to calculate area of the triangle, and that's area equals the base. You can think of the base as the bottom of the triangle times the height. Height is like from the bottom straight up to the top. Okay, so that has to be straight up, and quite often we'll put this little symbol here to tell you that that angle is 90 degrees. It's a square corner from the base up to the top. That's the height. And then whatever you get when you multiply the base times the height, you divide it by 2. And that gives you area of the triangle. Last one here. We're not going to do this as much this lesson, but in next lesson you're definitely going to use this all the time, is you need to calculate the area of circle. Circle, you just need to know one thing. You need to know what is the length of the radius. Radius is from the center to the edge, and actually if this is a true circle, which my circle definitely isn't, the radius would be the same from the center to any of the edges. So all of these edges would have the same radius. And if you know that, area equals pi, which is 3.14, and it continues on. It's just this huge decimal that goes on forever, times r squared. So r is your radius, and you just square it. So just remember, square means r times r. Okay. One thing I would like is if you could use the pi button in your calculator. So instead of typing in 3.14, I would much prefer if you use the pi button for it. It just gives you many more decimal places, which just makes it a more accurate answer. Okay, so I'd like you to do that in these questions. So let's try a question here. Okay, make sure you've got those tools written down. They're important. If you missed them, go back, pause it, get all those tools, those three formulas written down. But let's try a question here. Okay, so the first thing we're going to do is let's take our triangular prism. So just to remember, a triangular prism has triangles on the front and back, or on the top and bottom, depends where those triangles are, and rectangles on all the other three sides. So you can see here, if I was drawing a net of this, what I would probably do is I would probably draw this end triangle here, and you can see that distance here is 12 centimeters. This base part is 10 centimeters. And what you're going to have is you're going to have a rectangle like this. And then on the other side, you're going to have the other triangle. I'm just going to fold it flat out. Looks like it's the same dimensions. No reasons to think it's not. So it's 10 here, and it's 12 centimeters is from the bottom to the point here. And then there's going to be three sides to this. So there's the bottom, and then there's the two other sides. You can see that this length here is 18, which would be the same as this one, which would be the same as that length, which would be the same as that length. So you can see 18 are those ones there. Now the bottom is 10 centimeters. Now the interesting thing is, how long is this piece? And the answer is, I'm not sure. They don't tell us. 12 centimeters is from the base to the top, but you can see that'll be different from that piece. So we're going to have to think about how to calculate those pieces. Okay, so these pieces on this, we're going to have to think about this carefully. So let's start calculating some of these areas. So probably the easiest one, so I'm going to calculate the area of the triangle. So I'm going to just draw this here. And you can see the area, the triangle had a height of 12 centimeters and the bottom was 10 centimeters. So I'm going to just write the area formula. It's base times height divided by 2. So I'm going to just put a below this. I'm just going to keep my equal signs lined up. Now we're going to put in the number. I know what the base is. The base is the bottom of the triangle. It's 10 centimeters. I know the height. The height's from the bottom straight up to the top, which is 12 centimeters. And I'm going to divide whatever I get there by 2. So in this case, 10 times 12, we can do that pretty easy. It's 120. And we're going to divide 120 by 2, which gives me 60. Now this is the important. I've kept my units here, and I think it's good to keep your units. This is something that I think you always should do. A centimeter by a centimeter is just a centimeter squared. So this is basically what this is saying. If your base of the triangle is 10 centimeters and your height is 12, it would take 60 square centimeters to basically cover that whole triangle. 60 centimeters, and the centimeters are in a square shape. So it's a centimeter by a centimeter. So this squared here, when it's attached to the units, it doesn't mean square the 60. No. We've calculated it's 60 of these shapes it would take to cover that triangle. Good. So we've calculated this triangle, which is the same as that triangle. We could easily calculate this rectangle here because I know the length and the width. So let's do that. So let me get out my blue pen. So the next thing we're going to do is we're going to do this one, and it's 18 centimeters by 10 centimeters. So let's calculate that area. So area equals, the shape is rectangle, so go back to your tools, length times width. So I can just put the A right there, and I know the length. The length is my long side, which is 18 centimeters. My width is the short side, which is 10 centimeters. So fairly simply, 18 times 10, I love multiplying by 10, it's 180. And now the units, a centimeter by a centimeter, is what we call a centimeter squared. So this shape would actually take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would actually take 180 centimeters square to cover up this whole thing. So you'd actually need this many of them. So perfect. Last shape. Okay. These two are the same size, but the problem is I don't know the width. So how in the world could I figure out that length there? Well, here's the cool thing. We've been studying Pythagoras. What do we have here? We have a special shape. It is a right triangle. How big is this part of the right triangle? Well, it looks like it's cut in half, so if the whole thing is 10, half of it would be 5 centimeters. We know the height is 12 centimeters, so I could figure out this side. So how do we do that for right triangles? We have to do Pythagoras. A squared plus b squared equals c squared. Now remember, there's one thing we have to get in the right spot. The hypotenuse is across from the 90. It's the longest side. So I need to put this x, it's the longest side, it goes in for c because that's the hypotenuse. The 2 legs doesn't really matter. So this ends up being 12 centimeters squared plus B is 5 centimeters squared. So the question is, how do we go about solving this? Well, what you're going to do is you're going to do 12 squared, which is 144, 5 squared, which is 25, equals x squared. Now 144 and 25 gives me 169, which equals x squared. How do we isolate the x and get x by itself? Well, the opposite of squaring is square root. So the square root of 169, some of you probably know this off the top of your head, is 13. So I know that this hypotenuse here is actually 13 centimeters, which means this length is 13 centimeters, which means this length is 13 centimeters. So I now know that these sides here are 13 centimeters. So the last thing I've got here is I've got another rectangle. That rectangle looks big. 13 centimeter side, 18 centimeter side. Remember, area is length times width. So in this case, length is 13 centimeters times my width, which is 18 centimeters. Doesn't matter what order I put those in. And all together, 13 times 18. I might have to work this out. So 10 and 3. If you want to use your calculator, you probably could, but you probably don't need it for this one. 10 and 8. Just make our logarithm. 10 times 10 is 100. 10 times 8 is 80. 10 times 3 is 30. 3 times 8 is 24. So we add these up. 100, 130, 210, 234. So the last thing we need to do is we need to add up all our areas. So I'm going to just stack add this. So I've got 2 triangles. So I'm going to use black here. So my triangles, I've got 2. So each of them are 60. So I need 2 of those, or you could just say 120. I had 1 triangle, or 1 rectangle in the middle, which was 180. I had 2 rectangles on the side that were 234. So the last thing I need to do is add these up. Zeros plus 4, 2 4s give me 8. So 6 and 6 is 12, plus 8 is 20, plus 6 more is 26. 2, 3, 4, 5, 6, 7. So my answer is 768 centimeters squared. That's the surface area. If you counted all the areas of all the sides and you added them all up, the surface area is 768 centimeters squared. Well, I hope this gets you going. This was a tough question, but I think it's really worth our time and do it well. Have a good one, Math 8s.